Okay, so what we'll do now is we're going to look at a actual example. So here we have a rocket's projectile motion function is this, f of t. So if you remember back to our original equation, h of t is going to be minus 16t squared plus v of t plus h0. And if you remember, v of t, this is going to be the initial upward speed in feet per second, and h0 is going to be our initial height. So the height of our rocket when we start. Okay, so let's look at our equation here. Our equation is minus 16t squared plus 300t plus 1.5. So comparing our equations here, we can see that v is going to be 300 and h of 0 is going to be 1.5. Okay, so the initial speed of our missile, of our rocket rather, is going to be 300 feet per second, and the height of the rocket when we start is going to be 1.5 feet above the ground. Okay, so let's go and look at these. These questions. Okay, so the first question is the initial height. Okay, so initial height, very easy, is going to be h0, and from the previous slide we just saw h0 is 1.5. So our initial height is going to be 1.5 feet. Final answer. Okay, time to reach maximum height. So what's going to happen is that our missile is going to go up. The rocket's going to go up. It's going to reach a maximum height here, and then it's going to start to fall again. And what we want to know is we want to know the time t here when the missile reaches the maximum height. Okay, let's go back to our equation. Minus 16t squared plus 300t plus 1.5. Now, fairly obviously, we want to find the x coordinate of the vertex. That's the t coordinate of the vertex. So we want the t coordinate of the vertex. And how do we do that? Well, all we have to do is we have to find t is going to be minus b divided by 2a. And b is 300, so it's going to be minus 300 divided by 2a, which is minus 32. And you can calculate that. That is going to be 9.375 seconds, because we're measuring time. So after 9.375 seconds, the rocket is going to reach the highest point. Okay, let's work out the actual maximum height now. So actual maximum height. Okay, so basically We have our rocket. Like this. We know it reaches the maximum height at t is 9.375 seconds. So to find the actual maximum height, you're just going to substitute t equals 9.375 into our equation. So you're going to do minus 16, 9.375 squared plus 300 times 9.375 plus 1.5. So if we do that, we're going to get we should get 1407.75 feet. So the maximum height of the rocket is going to be 1407.75 feet. This is going to be our final answer. Okay, and let's go back to the final question. Total time in the air. Okay, so total time in the air. Okay, so basically what we're going to do here is our rocket is going to be traveling like this. This will be t equals 0. And we want to find the time at which the rocket hits the ground. So in other words, we want to find the x. We want to find the t coordinate here. So what is t? What is t here? That is basically what the question asks. So let's go back to our equation. Minus 16t squared plus 300t plus 1.5 equals 0. Okay, so we need to solve this, and you can do it using. I suggest the way you do it is you use Desmos, and you're actually going to draw y equals minus 16x squared plus 300x plus 1.5 on Desmos, and you're going to find the solution to that. So I'll actually leave that for you as an exercise. I'm not going to tell you the answer there. And if you like, you can actually check your answer using the quadratic formula. So x is going to be minus b plus or minus b squared minus 4ac over 2a. And obviously a is going to be minus 16, b is going to be 300, and c is going to be 1.5. So you can substitute these in, and you can find x from that. Okay, so we basically solved the problem here.